Good morning, students. Welcome back to the physics class. Today we are going to discuss a new topic. Already I started yesterday. A new topic, current electricity, unit 2. So there we discussed about two topics. The two topics is electric current and conventional current. I told you already the definition and explanation about the two topics. Now today our third topic is drift velocity. In this chapter, third topic is drift velocity. Okay, so now here we are going to discuss what is the drift velocity, what is the definition of the drift velocity, what is the expression of the drift velocity. Okay, so first of all, before going to the topic, just I explained already about the materials yesterday. Okay, so first thing, let us consider a conductor. Let us consider a conductor. This is the conductor. Each and every conductor having two types of particles, two types of charged particles, that is positive charged particle and negative charged particle. Each and every conductor having two types of charged particles. First one is a positive charged particle and second one is the negative charged particle. Okay, so this is the conductor. This conductor having positive charged particles and negative charged particles. Positive charged and negative charged particles. Okay, so here you can remember conductor having two types of charged particles. In that, positive charged particles does not perform any kind of motion. Positive charged particles does not perform any kind of motion. That will be always in stable position only, always in rest position only. Okay, so in that positive charged particles we won't consider. So we should consider only the negative charged particles. We should consider in a conductor only the negative charged particles. This negative charged particles is nothing but an electrons. What is the name of that negative charged particle in a conductor? Electrons. So this name is electrons. Okay, so positive charged particles does not perform any kind of motion, so we won't consider that negative or positive charged particles. Negative charged particles always we should consider in a conductor. So these negative charged particles, what is the name of that negative charged particles? Electrons. Okay, and these negative charged particles, that means electrons having random motion. These electrons will perform the motion is random motion. Random motion means it will move always any direction. It will move any direction. So this electron is there, it will move this direction and it will move this direction and it will move this direction. So these electrons will be perform random motion. Random motion is nothing but in any direction these electrons will be moved. Okay, so first of all what I did here, let us consider a conductor. This conductor having an electrons. Otherwise, let us consider a conductor. This conductor having two types of charged particles, positive charged particles and negative charged particles. Positive charged particles does not performing any kind of motion. Negative charged particles is performing random motion. The name of the negative charged particles is what? Electrons. Okay, yes. So these electrons are performing the random motion, correct. So suppose here also one electron is there. Suppose these I told you already what electrons are performing random motion, correct. So here suppose this electron is there, this will move in this direction and it will move this direction. All the directions this electron will be moved at that time. So this electron will move this direction and hit this electron. The nature of the electrons, the basic nature of the electrons in a conductor is random motion. The basic nature of the electrons is what? It will move randomly. So electrons are moving randomly means what will happen? This electron will move and hit this electron, correct. This electron will move and hit this electron. At the same time, again this will hit this electron and again it will hit this one. First this electron will be hitting this electron, after hitting this electron, that again this electron will be hitting this electron. So here what is happening here, because of that random motion, because of that random nature of the electrons, that electrons is making collision with respect to other electrons. You can remember, because of that random nature of the electrons, this electron is hitting these electrons, other electrons. That means this electron is making the collisions to other electrons. Okay, so here what for what reason I told like this means, suppose this electron is hitting this electron, it will take some time t1. Okay, this electron is moving, this electron having random motion, random nature. So this electron is moving like this. How much time this electron took here? t1 time. Again this electron is hitting again this in this electron, so it will take time t2. So the average time between the two successive collisions, the average time between the two successive collisions is called relaxation time or free mean time. What is that? Free mean time. Free mean time or relaxation time. Relaxation time. The average time between the two successive collisions. What is that? This electron is making collision. How much time? t1. Again this electron, same electron is hitting again this electron. So here how much time it taken? t2. So the average time between these two collisions is called, what is that? Average time between these two collisions. Here how much time? t1. Here how much time? t2. So that average is called as, average time is called as free mean time, otherwise relaxation time. Relaxation time or free mean time. Okay, so here this relaxation time, otherwise free mean time, we can indicate as the term tau. This name is what? Tau. Tau is nothing but a time, average time. So here the average time between the two successive collisions is called as relaxation time. Average time, no? So tau is equal to t1 plus t2 by 2. Remember, this electron is making collisions. Here taking some time t1, here taking some time t2. So the average time of the two collisions is called as relaxation time. That relaxation time we can indicate as the term name is what? Tau. Tau is equal to t1 plus t2 by 2. So you can remember always in this concept, whenever we are going to use the time t, whenever we are going to use the time t, we can write in the place of t, we can able to write tau. I hope you understood this. Average time between these two collisions is nothing but a relaxation time. Relaxation time we are indicating as a tau. Okay, this term name is what? Tau. Okay. So whenever in the after this topic continuously, whenever we are using the time t, small t, instead of that small t, I can able to substitute this tau. Just remember this term. Okay.